A process called synthetic division can be used to divide polynomials if the divisor has the form x minus c. So let's take a look at an example. I encourage you to pause the video and try to use long division to complete this process, dividing the polynomial 4x cubed plus 10x squared minus x plus 8 by x plus 4. In just a moment, I'll walk through the long division process and then show how we can solve the same problem using synthetic division, but I encourage you to pause the video and try to work through the long division solution on your own first. So for long division, I want to set up a bracket and put the terms of the dividend in descending order by degree. In this case, we have all the terms there, so I don't need to fill in anything with zeros, but if we had a missing term, I'd want to fill in some things with zeros. And we can put the divisor on the outside of the bracket. So now I want to take the lead term here, x, and divide it into the lead term of the dividend. X divided into that gives me 4x squared. And multiplying 4x squared with x plus 4, I get 4x cubed plus 16x squared. And now I want to subtract both of those terms. Of course, we set it up so that the 4x cubes now cancel. Subtracting the 16x, remember the minus sign carries through the parentheses, and we end up with a negative 6x squared. And bringing down the other terms, we get minus x plus 8. So now I have a simpler dividend that I want to divide into. X divided into negative 6x squared is going to give me minus 6x. And multiplying, I get negative 6x squared minus 24x. Of course, we want to subtract that. So the negative 6x squared cancels. And now subtracting the negative 24, it's going to become a positive 24, and so we end up with 23x. And we can bring down the plus 8 at the end, and we have one more step in our process. Plus 23 is going to be the last term in our quotient. Multiplying 23 by x plus 4, I get 23x plus 92. And I want to subtract that, and it gives us a remainder doing the subtraction. The 23x term will cancel, and subtracting 92 gives us a remainder of negative 84. And now the answer to our division problem can be written in a couple of different ways. If we write the division this way, it'll be equal to q of x, which is 4x squared minus 6x plus 23, the quotient, plus the remainder over x plus 4. And notice that since our divisor x plus 4 was just a degree 1 polynomial, the remainder has to be less than that, and so it really does just need to be a constant number, or in other words, a degree 0 polynomial. So that's the final answer to our problem. Now this particular problem lends itself to synthetic division because the divisor, we can think of the divisor as having the form x minus c, where c represents some constant number. To do synthetic division, we're going to set up a different type of bracket. We're going to put c on the outside, write the coefficients, just the coefficients of the quotient next to that, and then draw a line, and the coefficients of our quotient and the remainder are going to go underneath that line. So to do this, we need to identify what the value of c is going to be, and because our divisor is x plus 4, but the general form here that we're talking about is x minus a number, we can think of that x plus 4 as x minus negative 4. And so for this problem, to set up synthetic division, I want to put negative 4 outside of the bracket, and then write the coefficients of the dividend 4 and 10 and negative 1 and 8 along next to that. And now the process works in the following way. We bring down the first coefficient of the dividend. So I'm going to bring down the 4, and then diagonally I'm going to multiply 4 with negative 4. So 4 times negative 4 is negative 16. And then vertically going down, I'm going to add. So we multiply diagonally and we add vertically. And so adding those, I get a negative 6. Multiplying diagonally, negative 6 and negative 4 gives me a positive 24. Adding 24 and negative 1 gives me positive 23. Multiplying diagonally, 23, and we always multiply with negative 4. 23 times negative 4 is negative 92. And then finally adding vertically, we end up with negative 84. And so let me draw a line here in front of the last number, and what you may notice is these three numbers are the coefficients of q of x. Those three numbers are the values that we see in the quotient that we found from long division. 4 is the coefficient of x squared, negative 6 is the coefficient of x, and 23 is the constant term. And the number at the end is the remainder. So synthetic division, if you practice it and get comfortable with that, it can be a much quicker way to arrive at the answer. The two downsides are that it doesn't work for every problem, so you need to have specifically something in the form x minus c, and it gets detached from the variable. And so sometimes, interpreting the result can be a little bit, tricky. We have to be careful with how we interpret those results. One thing to help you kind of keep track of what the answer should be, if you start with an x cubed term, so the 4 is the coefficient of x cubed, and with synthetic division we're always dividing by a degree 1 polynomial, so that means we're going to go down, the quotient is going to be 1 degree lower than what we started with. So I know that the 4 is going to have to be the coefficient of an x squared term. I encourage you to take a moment and try working on this problem, dividing x to the 4th minus 7x cubed plus 3x minus 12 by the polynomial x minus 2. And I recommend you use synthetic division to try to work through that process. You could also use long division to maybe check your work to have an alternate way of coming up with an answer. Of course, the first step in synthetic division is setting up the bracket. I encourage you to pause the video for a moment and try that. Try to set up the bracket the way we did here. One thing to keep in mind is that when you write out the coefficients, you want to include every possible degree, starting from the highest degree down to a constant term. In just a moment, I'll show what the bracket should look like, but take a moment and try to think through it on your own first. So to set up the bracket, the value of c here is just going to be positive 2, because again the general form that we're looking for is x minus c, and that's what we have, x minus 2. And now the coefficients for the dividend are 1 and negative 7, for x to the 4th and x cubed, but since there's not an x squared term, we need to include a 0 and then a 3 and a negative 12. So if you didn't include a 0 in setting up the bracket, that would cause trouble, because since the variable isn't part of our expression here, without that 0 there as a placeholder, the calculation would sort of be interpreted as representing x to the 3rd power in my dividend rather than x to the 4th. So with that set up, go ahead and try to complete the problem, and good luck. I'm going to end the video here, but yeah, try to finish up that problem, and I hope you enjoyed the video. Thanks for watching.